A 500 volt 3-phase 50 Hz induction motor develops an output of 15 kW at 950 rpm. If input power factor is 0.86 lagging, mechanical losses are 730 watt and stator losses are 1500 watt. Find the slip, the rotor copper loss, the motor input and the line current of the motor. So basically we have three-phase induction motor which operates at 500 volt three-phase supply with frequency 50 hertz. After this, it develops output power of 15 kilowatt. That is mechanical output. It is 15 kilowatt, and the speed of the motor is running speed or actual speed is 950 rpm. If the power factor is 0.86 lagging, the mechanical losses are 730 watt. So mechanical losses are that iron losses, sorry, the mechanical losses are windage losses and friction losses, and the stator losses are 1500 watt. Okay, now we have to calculate slip, rotor copper loss, motor input and line current. So the given is VL, that is line voltage is 500 volt. If the voltage is not given, whether it is phase or line, then we will consider it is line voltage. The output power, that is mechanical power, is 15 kilowatt, that is 15,000 watt. The actual speed of the motor is 950 rpm. The power factor given is, that is cos phi 0.86 lagging. Mechanical loss, that is friction and windage loss, is 730 watt. And the stator losses, so stator losses both, that is copper as well as iron losses, that is 1500 watt. So this is related only with stator circuit. Now the one point is here not given, that is number of poles. Okay, because we have to calculate the slip, and for slip we need that synchronous speed, and to calculate synchronous speed we need number of poles. So since the data regarding number of poles is not specified, examiners are requested to award the marks appropriately to examinee who has attempted to solve the problem. So for this numerical, we will consider synchronous speed. Okay, now here the value of that the rotor speed is given 950 rpm. So we will consider synchronous speed directly, that is ns, which is near to 950. So synchronous speed near to 950 is 1000 rpm. Okay, so we have to take care that the actual speed of the induction motor is always less than the synchronous speed. Okay, so when we consider 1000 rpm, so near to 950 it is 1000. So that's why for now we will consider synchronous speed, that is 1000 rpm. Now find ns and es. Okay, so assuming synchronous speed 1000 rpm, which is close to 950 rpm, or assuming number of poles 6, but it is easy to consider that synchronous speed is 1000 rpm. Okay, now consider if you have given that the speed is 3000 rpm actual speed. So for this, the nearer synchronous speed is 1500 rpm. Okay, so by considering the scenario, you will choose the right synchronous speed. Okay, now ns is 120 f upon p. So 120 into f, that is frequency is 50 hertz, and the number of poles we are considering 1000 rpm. So basically this is 1000 rpm. So by using this we will calculate slip, that is ns minus n upon ns. So 1000 minus 950 divided by 1000. So the slip is 5% or 0.05. Now after that we will find a rotor output. So rotor output is P out plus mechanical losses. Okay, P out is the power which is developed by the motor and the mechanical losses. Okay, so output power is 15 kilowatt plus mechanical losses are 730 watt. So the rotor output will be 15.73 kilowatt. So this is the second step to calculate rotor output. Third step is find rotor copper loss. So we have one equation. You have to learn this equation, that is rotor copper loss divided by rotor output, which is equals to slip divided by 1 minus slip. So here we will consider the slip as fractional, that is 0.05, not 5. Okay, so if you consider 5, then the whole calculations will be wrong. So therefore rotor copper loss is equals to, by modifying this equation, S divided by 1 upon S into rotor output. So we have already calculated rotor output, that is 15.73 kilowatt. Okay, and in terms of watt it will be 15,730 watt. Okay, so by calculation the rotor copper loss is 827.89 watt. So these are the marks which are allotted according to the steps. Now step number 4, that is motor input. So motor input is nothing but the motor output plus all losses. Okay, so motor output we have 15,000, that is 15 kilowatt. Stator losses are given, that is 1500, and the rotor losses are 730 watt, and the mechanical losses 827.89. So here we are not considering the rotor iron losses. Okay, we are considering only copper losses. So here we will write rotor loss. So it is 827.89. So after addition, the addition of motor output and all the losses which are taking place in the motor, we have the final motor input. This is electrical power, that is 18,057.89 watt. So this is the actual input, electrical input given to the motor. Now the last step is find line current. So we know that three-phase power equation, P is equals to root 3 VLIL cos phi. Okay, so this is the electrical power, this is root 3, and line voltage, line current, cos phi. So by modifying this equation we can calculate line current. So IL is equals to electrical power divided by root 3 VL cos phi. So this is the electrical power, root 3 500 0.86 power factor, and the line current taken by the motor to deliver 15 kilowatt of output power.